This recording is made at Dream Chasers, a training center in Chennai, India. We can be reached at 9941436511. Our website is www.dreamchasersindia.com. Today we are going to look at trains. First case, train crossing a standing man. Now here we are going to use the formula speed equal to distance by time, because trains is just an extension of time and distance. So we'll always use speed equal to distance by time. Train crossing a standing man. This is a standing man. The train is coming in front of the standing man. I start my stopwatch. The train crosses the standing man. I stop my stopwatch. So the train has traveled this distance. The man is standing. The only thing that's moving is the train. Therefore speed refers to speed of the train. Distance traveled by the train is nothing but the length of the train, but by time taken for the train to cross a standing man, because the train from this place has moved to this place. So the entire distance traveled by the train is only from here to here, which is nothing but the length of the train. Since the man is standing and he is not moving, speed refers to speed of the train is equal to distance traveled by the train, which is nothing but the length of the train, by time taken for the train to cross a standing man. The standing man can be replaced by an electric pole or a lamp post, anything which is not moving and which has negligible length. Not moving and negligible length. Second case, train crossing a platform. This is the platform. The train is entering the platform. When the train is entering the platform, the front part of the train and one part of the platform are the same line. I start my stopwatch. The train crosses the platform. When we say that the train has completely crossed the platform, when the last part of the train and the other part of the platform are on the same line. So the train has effectively moved this distance. The platform is not moving, so speed refers to speed of the train equal to distance traveled by the train. This is length of the platform, this is length of the train. The train has moved from here to here, since it has covered length of the platform plus length of the train. So LP plus LT by T. So this platform can be replaced by a bridge or a tunnel, anything which has a particular length and not moving. So not moving and has some length. So we just add that length in the numerator. So ST is equal to LP plus LT by T. Third type. Two trains are moving in opposite directions with speeds S1 and S2 with the initial distance of D between them. Find the time taken for the two trains to meet. Now let's assume that the distance between the two trains initially is 600 meters. If the first train is faster than the second train, they will meet on the closer to the second train. Okay, at this side. They are equal means if the speeds are equal, they will meet at the center point. In order to meet, the two trains together will have to cover a distance that is equal to the initial distance between them. If 600 meters there, first train travels 400 means second train will have to travel 600. Will have to travel 200. Since they are moving in opposite direction, relative speed is S1 plus S2. Relative speed is speed of one object in relation to another object. Opposite direction S1 plus S2, same direction S1 minus S2. If you forget this, think of yourself going in a train. A train comes in the opposite direction, will appear to go very fast. So opposite direction means S1 plus S2. While another train comes in the same direction, will appear to be reasonably slow. You can even talk to the person in that train, so it's S1 minus S2. Here two trains are in opposite directions, therefore relative speed S1 plus S2. Together they cover the initial distance by time taken for two trains to meet. So S1 plus S2 is D by T. So T equal to D by S1 plus S2. Now fourth case, two trains have just met. Find the time taken for the trains to cross each other. Cross each other from the moment they meet. So two trains have just met. So the situation is like this. To cross each other, this train will have to go like this, that train will have to come like this. So they will have to cover L1 and L2, L1 plus L2. They are moving in opposite direction, therefore S1 plus S2 equal to L1 plus L2 by T. Fifth one is a combination of the third case. Two trains are having a particular distance. How long will they take to meet and cross, or they'll ask how long will they take to completely cross each other. So you will write S1 plus S2. To meet they have to cover D. To cross each other, they have to cover L1 plus L2. So to meet and cross, or to completely cross, D plus L1 plus L2 by time taken. The difference between fourth and fifth case is, in the fourth case, the two trains have just met. There is no distance between them. Here there is a particular distance between them, so that particular distance has to be travelled in order to meet, and then they have to cross each other. Now the third, fourth and fifth case in same direction will be S1 minus S2 equal to D by T, because two trains are in the same direction. The second train will have to cover D meters more than the first train. Suppose a person is 100 meters ahead of me and I am chasing him. If he runs 100 meters, I have to run 1100 meters to catch him. If he runs 1000 meters, I have to cover 1100 meters to catch him. In other words, the second person or the second train will have to cover D more than the first train. Since we are using relative speed, we are going to use relative distance. So S1 minus S2 is D by T. The fourth and fifth also you will have S1 minus S2 equal to L1 plus L2 by T. So S1 minus S2 equal to D plus L1 plus L2 by T. So in fourth and fifth case, again the right hand side will always remain the same. The left hand side only will be changed to S1 minus S2. Since the value of S1 minus S2 changes and the numerator value is the same, the value of time will change. Now if third, fourth and fifth case, if they say a train overtaking a man, you just have to put S1 plus S2 is L1 by T, because L2 is 0. And train overtaking a man, L1 by T. In opposite direction they will say cross, in same direction they will say overtake. Sixth case, you are sitting in a faster train and you are looking out of the window. You see the last part of the slower train. You start your stopwatch, then you go in front, and as soon as you see the front part of the slow train, you stop your stopwatch. Now they are moving in the same direction, so relative speed S1 minus S2 is equal to, what you have seen is the length of the faster train, length of the slower train, because you are sitting in the faster train, length of the slower train by time taken for a man sitting in the faster train to overtake the slow train. It is as if one man overtakes a train. Just because they have given one person is sitting in another train, it doesn't change anything. So please understand, here one man is overtaking a train. In the previous three cases, it was one train overtaking another train. Similarly, you are a person who is sitting in a slower train and looking out of the window. As soon as you see the front part of the faster train, you start your stopwatch. The faster train overtakes you. As soon as you see the last part of the faster train, you stop your stopwatch. Moving in same direction, therefore S1 minus S2 is equal to, what you have seen is length of the faster train by time taken for faster train to overtake a man sitting in the slower train. Please understand, the sixth and seventh is very similar to a fourth type when L2 is 0. Train overtaking a man is same as train overtaking a man sitting in a slower train or a man sitting in the faster train. When you are sitting in this faster train, you can only see the length of the slower train. When you are sitting in the slower train, you can only see the length of the faster train. Now the next type is birds. Two trains are coming in opposite direction with a distance of d between them. A bird sitting in front part of one train goes and touches the front part of this train. So this train would have come a particular distance and then comes back and touches the front part of this train. This train would have come a certain distance. Keeps on doing like this. Goes and touches the front part of this train, comes and touches this train, so on till the two trains meet. Find the time taken for the two. Find the distance travelled by the bird. Distance travelled by the bird. Distance travelled by the bird is nothing but speed of the bird into time. Time means time for which it is flying. Time of its flight. Speed of the bird into time of its flight. The time of its flight is same as time taken for two trains to meet. Time taken for two trains to meet is nothing but d by s1 plus s2. So the formula is sb into, therefore db is equal to sb into d by s1 plus s2 for opposite direction. If the two trains had been moving in same direction, you will write db is equal to sb into d by s1 minus s2. Now two trains are coming in opposite direction. They meet at a particular point, and after that, this is the first train, this is the second train. Okay, first train, second train. After meeting, the first train takes t1 time to reach the destination, while second train takes t2 hours to reach the destination. So they meet at a particular point. See, they start in opposite ends. Let's keep the two ends as A and B. Two trains are starting at opposite ends. They come and meet. After meeting, the first train takes t1 hours to cover this distance. This distance, okay, this is the total distance that's there. This is d1, this is d2. This is the distances. The speeds of the train are s1, s2. Time taken, t1 is the time taken for the first train to reach the destination. That is to reach B, while t2 is the time taken for the second train to reach the destination, that is to reach A. This is t2. Now the concept here is, before meeting, the two trains have traveled for the same time. Which means d1 by s1 is equal to d2 by s2. This is the first equation. After meeting, the first train takes t1 hours to cover d2. First train takes t1 hours to cover d2, which means speed of the first train is equal to d2 by t1. Similarly, second train takes t2 hours to cover d1. So speed of the second train is d1 by t2. This is your second and third. Now substituting d1 by t2 by t1 equal to d2 by d1 by t2. That is, you are substituting second and third in the first one. This implies, you take it to the other side, t1 by t2 equal to d2 squared by d1 squared, or d1 by d2 is equal to square root of t2 by t1. Whichever way you want, you can do it. The ratio of the speeds s1 by s2 will be the same as d1 by d2. Therefore, s1 by s2 is equal to d1 by d2 equal to square root of t2 by t1. You see which of this is given in the exam and do it. s1 by s2 is equal to square root of t1, or d1 by d2 equal to square root of t2 by t1. That is, it's inversely proportional to the square root of the time taken for the other trains, for that train to reach the destination. d1 by d2 is square root of t2 by t1. s1 by s2 is square root of t2 by t1. Just remember this. Again, I'll repeat the concept. Before meeting, the two trains travel for the same time. So therefore, time is same, which means d1 by s1 equal to d2 by s2. First train speed we write as d2 by t1 because the first train has taken t1 hours after meeting to cover a distance d2. Second train has taken t2 hours to cover a distance d1. So substituting, you will get this answer. It's a very important sum. This concludes trains. This recording was made at Dream Chasers, a training center in Chennai, India. We can be reached at 99414 36511. Our website is www.dreamchasersindia.com. Thank you.